Welcome back to Okunko Academy. So I would like to recommend that if you are new to this channel, you are going to subscribe to this channel and also put us on post notification so that you always be notified on every new video uploaded. So in this tutorial, we are going to concentrate on calculus 3, that is calculus with several variables. So first of all, let's start with functions of several variables. So in our previous study on calculus, we always come across functions with only one variable. As an example, we can get like y is equal to x squared plus 1, and now that y becomes our dependent variable and our x becomes our independent variable. So in the previous examples, we always see only one dependent variable, but in this tutorial we are going to talk about two or more dependent variables. So we are also going to concentrate on the domain of functions of several variables and also how to evaluate the limit of functions on several variables. So first of all, let's quick start with the first example. So with our first example, we have a function of two variables, that is x and y. We have f of x of y to be equal to the square root of 9 minus x squared minus y squared. So now someone may ask, how do we find the domain? So in order for us to find the domain, always need to get it in mind that the domain is basically the set of values of x and y that is going to make this function defined. I repeat, the set of values of x and y that's going to make this function defined. So let's consider the function that we have a radical, square root of 9 minus x squared minus y squared. So now we all know that for this function to be defined, the number or the value under the square root should either be greater than or equal to 0, because if the value or the number under it is less than 0, we are going to get a complex number which is going to make it undefined. So now we would know that the domain for the first example is just going to be 9 minus x squared minus y squared should be greater than or equal to what? 0. Right. Now with the second example, that is g of x of y, which has an expression of 3x plus 5y plus 2. Now we could see that this expression is a polynomial, and with the set of polynomials are always defined on the set of real numbers, because we could see that any value we are going to substitute for x and y, we are going to get a corresponding real value, which makes it a defined value, therefore the domain. So therefore we could see that for the second example, the domain is going to be our x comma y is going to belong to the set of all real numbers. Now with the third example, we have three different variables. So now with the third example, for this function to be defined, we have two conditions, right? So the first condition is the denominator cannot be equal to 0, because if the denominator is equal to 0, then we are going to get infinity, which is outside the set of real numbers. And also the radicand, that's the expression under the radical, the square root sign, must not be negative. That means that our expression there, that's 9 minus x squared minus y squared minus z squared, should not be what? Negative. That it should be greater than or equal to what? 0. So now combining these two conditions, the first condition being the denominator not equal to 0, and the second condition being the radicand not being negative, we are going to get a domain which is 9 minus x squared minus y squared minus z squared is greater than 0. So someone may ask, why is it that with the first example we have greater than or equal to 0, and the second example it is greater than 0? So this is because of the first condition. Because with the first condition we are saying that the denominator shouldn't be equal to 0. So that means that that's going to get rid of the equal to sign, making our expression 9 minus x squared minus y squared minus z squared being greater than 0. Now with the fourth example, we also have a function h which has 3 dependent variables, x, y, and t. So now with this second function, we could also see that for it to be defined, 2 conditions must hold. The first condition is the radicand cannot be negative. That's 2t minus 4 cannot be negative, and also the denominator cannot be 0. That's x squared minus y squared cannot be equal to 0, right? Okay, so now having understood the concept of domain, let's move on to the concept of limit. So now with the concept of limit, as we did in calculus 1 and calculus 2, we are going to apply the same idea in calculus 3. As in evaluating the limit in calculus 1 and 2, we just substitute the value for x. That's the value at which the x is approaching. We just substitute and get the limit of the function. We are going to transfer that same idea under functions of several variables. So now let's say, taking equation b, that's the second example, we having g of x of y being equal to 3x plus 5y plus 2. Let's say we are to evaluate this function whilst x comma y approaches a certain value. So let's say they approach 2 comma negative 1. So now how do we evaluate this limit? So the limit as x of y approaches 2 negative 1 of g of x of y is just going to be we substituting the value of x and the value of y. So now we are going to get 3 multiplying 2 plus 5 multiplying negative 1 plus 2. So now you are going to get this one to be 6 minus 5 giving us 1 plus 2 giving us 3. So therefore the limit of g of x of y as x comma y approaches to negative 1 is 3. So the same thing applies to all these 4 functions. So now let's take function h, that's the fourth one. So now with this fourth one we have 3 variables, that's x, we have x, y, and t. So let's say these variables approaches the value 1, 3, and 5. So now what we are going to do is that we are just going to substitute the value of x, y, and t as we did for the previous one. So now our value for h is going to be the square root of 2 times t, which is 5, minus 4, all divided by x squared, which is 1 squared, minus y squared, which is 3 squared. So now evaluate, we are going to get square root of this. 2 times 5 will give us 10, minus 4, that's square root of 6, divided by 1 squared will give us 1, 3 squared will give us 9, 1 minus 3 will give us negative 8. Thank you for your time. See you in the next tutorial, which we are going to consider continuity and